Okay, Borger High School. This is for Miss Howard's 10th grade chemistry class. This is nuclear chemistry. And we have several things that we'll be covering with this unit. However, what we're going to be focusing on is C6A, understand the experimental design and conclusions used in the development of the modern atomic theory. Remember those guys, Dalton, Thomson, Rutherford, and Bohr. Those are the four big dogs that you have to know. This first video should just be a review of what you should already know about the structure of the atomic theory, or the atomic design, the design of the atom. Let me get that right. Okay, so Roman numeral number 1, atom history review. You guys remember John Dalton? He's the guy that came up with the basic atomic theory. He said, number 1, all matter is made of atoms. Atoms of the same element are chemically alike. Atoms of different elements are chemically different. Atoms of the same element have definite average masses, and remember we have an equation for calculating the average mass of an element, or all the isotopes of the element. Atoms of different elements have different masses, and atoms can't be split by ordinary chemical means. Now, the vast majority of the school year we've talked about just chemical means. With this unit, we'll be talking a little bit about the nuclear means. Not that we're going to do anything of it in class, but this is the only section where we talk about, yeah, we can actually split the atom, but it's not an ordinary chemical means or process. Letter B, Dalton thought atoms were indivisible. Remember, that was the one big thing that was wrong on Dalton's theory. But after this Henri Becquerel discovered that radiation was present, he's the one that said, hey, this is proof that atoms are divisible, not invisible, people. Indivisible and divisible. Pay attention to the words. So, Thomson came along. This is going to irritate me. Thomson came along and discovered the electrons in 1897, and he used the cathode ray tube setup. And he, remember, figured out that electrons have properties of both particles and waves, and they're affected by magnetic fields. There's a little diagram down in the bottom of the picture here that shows you, remember that he put a cathode ray tube, that he put a magnet up to the cathode ray tube, and it bent what was quote-unquote light, and so he realized, hey, this is not light. And he also came up with the plum pudding model of the atom. Remember, the basic mass of the atom was positive, and there were just negative charges that were just kind of stuck in there like I don't know what plum pudding is. So it's like, I always think of it as that fruit jello, where you've got little pieces of fruit stuck in the jello. So the positive part would be the jello part, and the fruit part would be the negative electrons. Okay, so he used a vacuum tube with an anode and a cathode on the other end. And he placed a fluorescent screen inside, and he aimed the cathode beam along it, and then he put a magnet near it, and it bent that ray that was there. The glow on the fluorescent screen, that was the little string of light, that would be what bent it. And again, this proved that the glow just wasn't simply light. It had to have something, because light's not going to be bent by a magnet. So he proved that, okay, something's got to be there. And he didn't stop there, though, and this is the key thing in science. He did the exact same experiment, but he changed a variable at a time, and he did all sorts of variables, changed different materials for the glass, different materials for the fluorescent screen, different materials for the anode and the cathode, and he always got the same result. He said that the glowing particles then were little electrons, and if you translate that from the Greek, it would mean beaming suns. Then along comes Rutherford, 1911, and Rutherford's the guy that discovered the nucleus. Remember, he used that little, the famous gold foil experiment. He said the nucleus was the tiny but massive central area where the protons and the neutrons were found. And he said also that the atoms are mostly empty space. The main mass of the atom is the nucleus, but the volume of the atom is mostly empty space where the electrons are. Hang on just a minute. I'm going to yell at my husband. Hey, she's scratching at the door. Will you come get her? Sorry. Yeah. Thank you. Oh, they're both coming out. Okay. Okay, so in this case, they're talking about if you could bring the atom up to the side, that you could actually see, like, the neutron, or the nucleus would be a marble. Then if you placed it in one of those big stadiums, then if you put the marble on the 50-yard line, the whole volume of the atom would be the whole entire dome, or the Astrodome in this case. So it's mostly empty space again. But again, the mass is located in the central area, in that nucleus. Okay, so his famous gold foil experiment, again, this is something that you guys should remember. We did a great lab showing how we could calculate the diameter of something even without touching it and measuring it. He shot large alpha particles, and this is where we're talking about. We talked a little bit about the alpha particle in class before spring break. He shot those large alpha particles, which is a helium nucleus basically, at a thin gold foil, and he surrounded the whole thing with a phosphorescent screen. And he looked on the screen to see if any of the particles were deflected, because when they hit the screen, they would light up. So the vast majority of them are going to go straight through. However, so most of them went straight through, and that said, yeah, even the densest material we could have is still pretty porous. But he could measure the angle of deflection, and he could figure out that, yeah, it's very porous, but some of these things were deflected, so there's something there. So here's a lovely picture, a little diagram of his gold foil experiment. Atoms have a positive charge. It's located, the positive charge, let's start it this way, in the atom is concentrated in the nucleus. And it's the opposite charge of the electron. They arbitrarily named them a positive and negative charge. And then the mass of the proton is 1,840 times the mass of the electron. That's for the most part why we kind of ignore the mass of the electron in chemistry. We don't kind of. We really do ignore the mass of the electron. Okay, the atomic structure, now we're coming along to Niels Bohr. Niels Bohr discovered that the electrons orbit the nucleus. So now we've got the electrons, we've got the nucleus, and now we're trying to figure out where exactly are the electrons there. And so he's saying, hey, they're orbiting the nucleus. So he came up with this planetary model of the atom, and it's still the easiest of our models to draw. Not the most correct, but it's the easiest to draw and kind of say, hey, this is giving us an idea of where those electrons can be found. So again, on this little set of notes, we mainly focused on understanding the experimental design and conclusions used in the development of the modern atomic theory. Dalton, Thomson, Rutherford, and Bohr. And I don't know why that keeps coming up, but I'm not going to mention it again. We'll pretend like it doesn't exist. It comes up, I let it go. All right? You've got 3 more videos to watch and get the notes on, all during spring break. Oh, happy day!